Hello everyone, welcome to SCI-EASE. You have learned how we arrange electrons in the orbits or shells. The electrons which are present in the outermost shell or the orbit, that is known as valence electrons. And the shell in which these valence electrons they are present, these shells are known as valence shells. Means outermost जो shell है उसको हम valence shell बोलते हैं और उसमें जितने भी electrons हैं उनको हम valence electrons बोलते हैं. And we have read this thing also, that the outermost shell can have maximum of 8 electrons. In case of some of the elements like helium, neon, argon, etc., which are inert gases or noble gases, their outermost shell that is complete. In case of helium, it has 2 electrons in its outermost shell, means first shell. This is a nucleus and there are 2 electrons in its outermost shell. This means duplet. Here we will say that duplet is complete. And in the next shell, the maximum electrons that can be accommodated, they are 8. So I will draw the structure of neon. This is the first shell and this is the second shell. Okay. Here, 2 electrons in the first shell and 8 electrons. 2, 3, 4, 5, 6, 7, 8. So, here we will say that its octet is complete. Every element has a tendency, every atom has a tendency to acquire this octet configuration, means noble gas configuration. This means they want stability. Every atom wants stability. Okay. So here, in case of helium, neon or argon, you can draw the structure of argon on your own. In the third shell, again the octet is complete, 8 electrons. Electronic configuration is 2, 8, 8. So total of 18 electrons they are present. This means they have chemical stability. In this case, this atom then that can exist, this element, helium, neon, argon, krypton, all these inert gases, they can exist in the atomic form because their octet is complete without any reaction with some other atom. So in this case, their valency is 0. Their valency is 0. In all the inert gases, starting from helium, neon, argon, krypton, xenon. Okay? In all these cases, octet is complete. In helium, duplet is complete. In other cases, octet is complete. This means their valency is 0. They need not combine with some other atom to gain the stability. Okay, they are already stable. So they can exist in atomic form. He will exist as He. Ne will exist as Ne. But when we will take the case of some other elements, like we take the case of hydrogen. Hydrogen is unstable because there only one electron is there. Either it should gain the electron or it should lose this electron to acquire stability. So what is valency? It is the combining capacity of an element. Valency is the combining capacity of an element. That is how much atom bonds with another atom. Therefore, capacity of an atom to give, accept or share electrons to achieve the stable configuration, it is called the valency. Now I will take up some of the examples like sodium. I will take up the case of sodium. Okay. You know, I will draw the structure of sodium. This is the nucleus, this is the first shell, and this is the second shell, and this is the third shell. Okay. So, how many electrons? In the first shell, 2, because it has atomic number 11. Its electronic configuration is 281. So, here 8, 1, 2, 3, 4, 5, 6, 7, 8, and this one loosely held electron. Okay. How it can acquire the stable configuration? When it will lose this electron. When sodium lose this loosely held electron, then it will acquire the octet configuration or the configuration of neon. पर वो किसको देगा? किसी और एटम को देगा? You take the case of chlorine. You take the case of chlorine. It has atomic number 17. Okay. So it will be 287. First shell, second shell, and third shell. This is the nucleus. Okay. 2, 8, and 8. How many? 7. So this one electron, if sodium loses one electron and chlorine gains one electron, what will be the result? Both the atoms, they will be stable. So this will lose this electron, and chlorine, that will gain the electron. When it will lose, it will acquire +1 charge, and when it will gain, it will acquire 1 electron it's gaining, so it will acquire the negative charge. I want to tell you that when you see the periodic table, the elements present in the first group, that is lithium, sodium, potassium, rubidium, and so on, alkali metals, they all have 1 electron in their outermost shell. So they will lose this 1 electron and they will acquire the noble gas configuration. In the same, so when we know the number of the electrons present in the valence shell, we can tell the valency of an element. So all the elements present in the first group has valency 1. Now come to the elements present in the second group. Beryllium, magnesium, calcium. Okay? So all these elements, periodic table जब करोगे तो फिर ये 10th में तो पूरा डिटेल में पता चल जाएगा. अभी आप ये याद रखो. ठीक है? Beryllium, magnesium, calcium. Okay? So they have 2 electrons in their valence shell. This means the valency of the elements present in the second group, that is 2. Come to the case of aluminium. It has 13 atomic number. So its electronic configuration will be 283. So these 3 electrons, if aluminium loses, it will acquire the noble gas configuration of neon. So it will lose these 3 electrons, and who will gain 3 atoms of chlorine. I will draw the structure. Aluminium, it has 13 atomic number, electronic configuration 283. So what will be the result? This is one shell, this is second shell, this is third shell. Okay, so here 2, 1, 2, 3, 4, 5, 6, 7, 8. And this is 1, 2, and 3. Okay. Chlorine, you know that it has 7 electrons in its outermost shell. So it can accommodate only how many electrons? 1 electron. So these 3 electrons that will be given to 3 chlorine atoms, and it will acquire Al3 positive. So valency of aluminium, it will be 3. Okay, so it will also gain the noble gas configuration, or you can say its octet, that is complete. Octet of this chlorine is complete, octet of this chlorine is complete, and octet of this chlorine is also complete. Okay, so in all these cases, I have told you capacity of an atom to give, it will give, this will accept or share. Now I am taking up the case where the electrons, they are shared. They can share with the same atom or different atom. I will take up the case of hydrogen molecule. One hydrogen, it has 1 electron. And this hydrogen, it has 1 electron. In this case, 1 electron is less, and in this case also 1 electron is less for the hydrogen to acquire the stable configuration of helium. Okay, so what will be the result? This hydrogen will share this electron, and this hydrogen will share this electron. So here the sharing of the electrons takes place. Okay, and it will acquire the noble gas configuration. In the same way, when you take the case of HCl, here 7 electrons, you can put dots or cross, whatever you like to be. So it will be, hydrogen has 1, this is this electron, it will share this electron, and chlorine will share this electron. Result will be the formation of HCl. Here H2 will be formed, and here HCl, that will be formed. So what is valency? That is the combining capacity of an atom and the number of the electrons which are present in the outermost shell, that is the valency. But I want to tell you one thing. Here I say that valency of chlorine is -1. How? It has 7 electrons in its outermost shell, so it should be 7. No, valency can be calculated in 2 ways. One is the outermost electrons which are present in the valence shell, that is a valency. Or in this case, like all the halogens or chalcogens, oxygen family, okay? And halogens, fluorine, chlorine, bromine, iodine, okay? In these cases, if I will remove these 7 electrons, lot of energy that is required. Okay, so it will accept 1 electron and it will acquire the stable configuration. So in this case, in halogens or chalcogens, oxygen family, how we calculate the valency, that is 8 minus the number of electrons present in valence shell. Okay, so here number of electrons present in the valence shell in case of chlorine, it is 7, so valency will be 1. Okay, because it's gaining, so it will be minus 1. In case of oxygen, you take the case of oxygen, it has 6 electrons in its outermost shell. Oxygen, 6 electrons in outermost shell. 8 is the atomic number, electronic configuration, that is 2, 6. So 8 minus 6, the valency will be 2. Okay, here it's minus 2 because it's gaining the electrons. I hope the things, they are clear to all of you. What is valency? It is the combining capacity of an atom. And how we can calculate the number of the electrons present in the outermost shell or the valence shell, or 8 minus the number of the electrons present in the valence shell. So it's very important how these compounds, they are formed, either by accepting the electron or by losing or giving the electrons or by sharing the electrons. Okay, that tells us about the valency. Every atom has a tendency to acquire noble gas configuration. This means they want to be stable. हम भी तो लाइफ में स्टेबिलिटी चाहते हैं ना. रोज हमारा स्कूल अगर चेंज कर दिया जाए तो स्टेबिलिटी रहेगी? नहीं. In the same way, atoms also want that they should be stable. And how this stability that is acquired? That is by gaining, losing, or sharing the valence electrons present in the valence shell. So that's all. With the term valency, I think the things, they are clear to all of you. I will come in the next video and take up the topic atomic number and mass number. Till then, thank you very much.